need to investigate if f vector is a gradient vector or not. So when the f vector be gradient vector, if and only if its curl is 0, that is curl of f vector should be 0. If the curl of f vector is 0, then f vector is a gradient vector, otherwise it is not. So these are the three paths given to us and we need to check that which of one is a gradient vector. So there is a remark. F vector is gradient vector if and only if curl of f vector is equal to 0. And how do we find the curl of f vector? That is equal to the determinant of this, right? Where f vector is f1 I vector plus f2 j vector plus f3 k vector. Then is if r vector, that is your position vector, is xi vector plus yj vector plus zk vector, then mod of r vector is square root of x square plus y square plus z square. That is equal to r only. To find curly r by curly x, so that will be equal to curly by curly x of this square root of x square plus y square plus z square, right? So this is equal to 1 divided by 2 square root of x square plus y square plus z square into 2x. So this 2 will go and we are getting x divided by, this is nothing but your r, right? So curly r over curly x is x by r. Similarly, curly r by curly y is y by r. And curly r by curly z is z by r, right? Please keep in mind these steps which are helpful. So this is the first part and f vector is given to us. This is your f1, f2, f3. We have to investigate that is this f vector is a gradient vector or not. So for that, let's calculate the curl of f vector. So that is equal to determinant I vector, j vector, k vector. And here we write curly by curly x, curly by curly y, and curly by curly z. And writing here the first component, that is minus 2z square x. Then is 3y square z. And then is y cube minus 2zx square. If this determinant is equal to 0, then f vector is a gradient vector. So this is equal to I vector. So this is curly by curly y of y cube minus 2zx square minus curly by curly z of 3y square z minus j vector. It is curly by curly x of whatever way you like to do, you can do by that way. Y cube minus 2zx square curly by curly z of minus 2z square x. Then plus k vector curly by curly x of 3y square z minus curly by curly y of minus 2z square x. So that is equal to, okay, derivating this with respect to y, we are getting 3y square. So this is I vector into 3y square minus derivating this with respect to z, we are getting 3y square, right? Minus j vector. Derivating this with respect to x, we are getting minus 4zx. Derivating this with respect to z, we are getting minus 4zx again, and that becomes positive. And then derivating this with respect to x, it is 0. Derivating this with respect to y, again 0. So this cancels out and this also cancelled out. So we are getting the curl of f vector to be equal to 0. And because the curl of f vector is 0, so f vector is a gradient vector. So first part is a gradient vector. Let's check the second one. Now here f vector r is equal to k vector into fr. That means we are having only the third component of f vector, right? So let's calculate the curl of f vector. That means this is your f3 only. So this is the determinant of So now there is no first component of f vector, so this is 0. And there is also not a second component of f vector, that is this is also 0. And third component is f of r. Right? So this is equal to, solving this determinant, I vector into, okay, curly by curly y of f of r minus, this is 0, minus j vector, and then we are having curly by curly x of f of r minus, this is again 0, plus k vector, and then both are 0, 0 minus 0. So that is equal to I vector, okay. What is curly by curly y of f of r? It is f dash r into curly r over curly y. Derivating r with respect to y, right? Minus j vector. What is curly fr by curly x? It is f dash r into curly r by curly x. And then rest is 0. So this is equal to I vector, okay. This is f dash r. What is curly r by curly y? It is y divided by r, right? Similarly, curly r by curly x is x divided by r. So this is y divided by r minus j vector f dash r, and this is curly r by curly x, that is x divided by r, right? So taking f dash r common, so this is f dash r into I vector y divided by r minus j vector x divided by r. That is equal to f dash r divided by r into y I vector minus x j vector, which is not equal to 0. So the second option is not a gradient vector. So the second option is not a gradient vector. So this is not a gradient vector, as curl of f vector is non-zero. Okay, let's go for third. So third one is f vector equal to r vector into f of r, right? So here what we are having now, f vector is equal to, writing r vector as x I vector plus y j vector plus z k vector into f of r. So the first component of f vector becomes x into f of r I vector plus y into f of r j vector plus z into f of r k vector. So let's calculate the curl of f vector. So the first component is x into f of r, then is y into f of r, and then is z into f of r. That is equal to I vector. Okay, so this is curly by curly y of z into f of r, that is first function derivative of second function with respect to y, that is f dash r into curly r by curly y, right? Then plus second function derivating z plus second function derivating z with respect to y, that is 0. Then minus curly by curly z of y into f of r. So that is first function derivating f of r with respect to z. So that is f dash r into curly r by curly z. Then plus second function into derivating y with respect to z. That is again 0. So that's it. Similarly, minus j vector plus k vector. Simplifying further, we are getting this, okay, z into f dash r. What is curly r by curly y? It is y by r, right? minus y into f dash r, curly r by curly z is z by r, minus j vector z into f dash r, curly r by curly x is x divided by r, minus x into f dash r, curly r by curly z is z divided by r, plus k vector y into f dash r, curly r by curly x is x divided by r, minus x into f dash r, curly r by curly y is y divided by r. Right? Okay. So here if I take f dash r common from this, then what we get? zy by r minus zy by r. That will cancel out. So this cancels out. Then again, if I take f dash r common from this, what we are getting in the bracket? Zx by r minus zx by r. That cancels out. Again from here, if I take f dash r common from this, what we are getting in the brackets, it is yx by r minus xy by r. That also cancelled out with each other. That means we are getting 0. So curl of f vector is 0, which means this f vector is a gradient vector. So this is your gradient vector. So out of the 3 options, only first and third is a gradient vector.